With the understanding of domain and range, let's consider compositions of functions. Suppose fxy is a function mapping values of x to the codomain y, and g is function mapping stuff from the domain y to a codomain v, and they are just two functions. We can define a new function, g of f, as the composition of f and g. Here, we should quite precisely say it's the action of f followed by g. In particular, g of f is a function from the set x to v, where the rule is written as g of f of x. Think about how composition of functions work. From the initial domain of f, which is x, f will map it to some image in y, which is a subset of y. It may not necessarily be the whole of y. Then g has domain y, and the image or the range of f is a subset of the domain of g. In other words, image of f is a subset of y. Therefore, we can define g of f. Now the new domain would therefore be x to v, because that's the codomain of g. So the composition of g of f is essentially going through the domain of f to the domain of g, and then to the codomain of g. This is what's happening with the rule conceptually. Here we don't discuss how to graph a particular composition of functions. For example, we don't discuss, you say, how to graph e of sine of x. But you need to be understanding the concept of domain and range in order to truly understand the concept of compositions of functions. In particular, consider two functions, f x to y and g to z. Does f of g or g of f need to exist? When do they exist? How to make them exist? That is the fundamental question you will need to solve. Let's, for example, consider when would g of f exist. This is the domain of f, which is x. The rule f of x maps the domain to some particular image, which we call image of f, or the range of f. Now, g of f of x can only work if f of x is in the domain of g, or f of x is in g. In other words, we need the whole of the image of f to be in the set of the domain g. In that case, then, the function g of f can map this image to some new codomain z and some new image of the resultant f g of f. That's the important result. G of f exists if im of f is a subset of the domain of g. Importantly, the image or the range of g of f is not necessarily the same as the image of g. This is because the domain, the image of f may not cover the whole of the